Hello dear students, today we will look at the lab on parameters of a power transformer. You can go over the theory. Let's look at procedure part A, short circuit test. So we have to short the low voltage side and supply power to the high voltage side. The transformer which we will use is the same transformer that we have been using in the previous labs, and we will use the ratio 240:56. So our primary side is 240 volts and our secondary side is 56 volts. So please look at the figure for part 1. Okay, so in the primary side we have to connect a ammeter, a watt meter and a voltmeter, and in the secondary we have to connect it via a wire. So basically the secondary is short circuited. Please refer to table A. So I will apply the primary voltage as per the table, and you have to fill in the current and the power. So the first one is 5 volts. Okay, so that's 5 volts. Please record. The first one is voltage, then you have current in amps, and then power in watts. Next, 10 volts. Okay, please record. Next, 20 volts. Okay, that's 20 volts. Next, 30 volts. Next, 40 volts. So we are at 40 volts now. The current is 0.102 amps and 4 watts. So we have to keep increasing the voltage until we get the rated current of the secondary winding. So the secondary winding is rated at 0.15 amps. Okay, so we have to still increase the voltage. So let's go to 50 volts now. Please record. Now we are going up till 60 slowly, keeping in mind the current should not exceed 0.15. Okay, so at exactly 60 volts we have 0.15 amps. So please record. So that concludes the first part, which is the short circuit test. Let's return the voltage to 0. and 10 off the power supply. Okay, now let's move on to part B. Here we will look at the open circuit test. So what we have to do is supply power to the secondary side and observe the voltage produced in the primary side. Please refer to table B. So I will change the voltage and you have to record accordingly in the table. The first meter will show you the primary voltage. The second meter will show you the secondary voltage, current and power. Okay, the current is in amps and power is in watts. Okay, so the first voltage is 10 volts. Please record. Next 20 volts. Please record. Next 30 volts. Next 40 volts. Next 50 volts. So at 50 volts we are almost about to reach the primary winding voltage. So we will go slow now. Please observe the primary winding voltage. So we are getting 240 volts at a secondary input as 57.3. Okay, so that should be your last reading in the table. Okay, so that concludes part B. Let's turn the voltage down to 0 and turn off the power supply. Okay, now similar to what we did in part B, in part C we have to do open circuit test again, but this time the low voltage side will be the open circuit side. Please refer to table C. So I will increase the primary voltage from 40 up till 264 and we will observe and record the secondary voltage. So the ratio again is 240 is to 56. This meter will give you the secondary voltage. This one will give you primary voltage, primary current in amps and power in watts. So the first voltage is 40 volts. You may record now. Next 80 volts. You may record now. Next 120. Next 160. Next 200 volts. Next 240. So you can see at 200 at 240 volts we are getting 56 volts as the output. So the ratio has been maintained. If we keep going, the output will increase further. So this should be your last reading. Okay, now we turn the power supply to 0 and switch it off. Okay students, so for our last part we will be looking at the rated load test, and we will be using the resistive load. So here on the secondary side we have connected a resistor after doing the calculation considering the output voltage as 56 volts and the rated current as 0.15 amps. I'm sure you can do the calculation and get the value of your RL. So I will apply 240 volts to the primary side, and we will observe the input current, voltage and power, as well as the output current, output voltage and output power. This is the resistor which we have connected. There are a few resistors connected in series to get the accurate value of RL. Now let's turn on the power supply and adjust our input voltage to 240 volts. So as you can see, our input is 240 volts now. Please record the input voltage, current and power, as well as the output voltage, output current and output power. This meter is for input, this meter is for output. So as you must have noticed that the input power and output power is not the same. This is because the transformer has internal losses, which you have learnt in your lectures, and it is also mentioned in the lab handout. These losses are due to loss due to heat and core losses. This concludes our last part for this lab. Thank you.